battles. That would be hilarious. Okay. All right. So this week we're going to completely transition into a new topic. So we're done with the conversation of rigging for the moment. So it's time to move on to something that's definitely far more exciting and interesting than the stuff that we've been exploring the last couple of weeks. Today we're going to talk about animation in a new light. Today we're going to be looking at simulations and dynamic animations that are influenced by global parameters. Over the past couple of weeks we've been exploring the art of animation through the traditional modality, keyframes, by having a control point, keyframes, and by moving those control points and setting these keyframes, we're able to drive and generate a movement. Okay? But what's the problem with keyframe animation? It's tedious. It requires a tremendous amount of work, right? Where do we see traditional keyframe animation being applied the most? Short films, and specifically where within those short films? Characters, yeah. Keyframe animation is something that we really want to use and honor in the traditional character animation pipeline. Why? What do keyframes give us in the character animation pipeline when compared to others? Poses? Control, absolutely. We get to control beyond any reasonable doubt where and how our characters are going to be posed within our scene, right? This is really, really important and crucial for when you're trying to establish a performance, right? We want to have that human interaction and that connection between the audience and the animations that we're seeing on screen. So keyframe animation is perfect for traditional performance-based mediums, short films, things like that, okay? However, it's not the only animation type that we have available to us inside of our 3D modeling applications. Today we're going to explore the other side of the coin. Today we're going to explore dynamically simulated animations. So we're going to ask the computer to establish a whole series of movements that will ultimately give us a really cool result. Keyframe animation also, well, let me step back and rephrase that sentence here, okay? It's very difficult to achieve the illusion of gravity and the illusion of weight and interactivity with traditional keyframe animation, right? Animators spend their entire life focusing on creating the illusion of weight and sustaining that idea of gravity through their movements. It's very difficult, very laborious, extraordinarily hard. Well, today, however, we're going to look at a way for us to easily infuse gravity and make our objects move. Okay? In many ways, we're going to revisit our bouncing ball exercise again. I want to walk through some of the parameters in the bouncing ball traditional keyframe modality that will act and serve as a comparison between the two. Now, before we get too much into this, a lot of people, I know what you guys are going to do. I've been teaching this long enough that I instinctually know what you're going to do. You're going to try to make everything a simulated event going forward, right? Everything is going to be simulated. Even your characters are going to be simulated. No. There's only a certain range of applications for simulated effects, okay? Let's talk about where you see simulated effects the most. Where do you see them? Simulations. Where would a simulation really be the best tool? Video games. Get a little bit more specific than that.
In a situation where a character or your target uses control or something?
Kinda, a little bit. Think bigger. Yes. Explain to me what the hand signal meant. Explosions, right, absolutely. Simulations are really great for small things. If you think about it, how in the world are you going to animate, shards of glass shattering? You're not going to hand animate that, right? How in the world are you going to hand animate through the keyframe process an explosion, smoke, flames, boxes falling on the ground? These are all traditionally very difficult things for us to quickly craft using traditional keyframe animation, okay? Perfect for dynamic simulations because we want the computer and the parameters that we set within the scene to control the movement and infuse those small little gravitational pulls and rotations to generate the animation for us, okay? So in many ways, this is not a replacement for keyframes. So don't think that it's like, oh, I don't have to study keyframes anymore. No, that's not the case, okay? Simulations have a very important role, but we need to pick and choose when we use them. For traditional character-driven animations, the performances, those are always going to be keyframe-driven. Everything else, now we have to start picking and choosing when we want to use simulations and when we want to use keyframes. Okay? Let's start today off by just doing a very simple kind of refresher. on the animation pipeline inside of Modo. I know that we've been really focusing a lot on rigging in the past couple weeks, so I just want to revisit and refresh everyone's memory on how we get things to move inside of Modo. I'm doing this not to necessarily underscore the tools and the techniques, but to draw a comparison between the results and the workflow. Okay? So let's just do it real fast. I'm going to create, let's go into my model tab. Of course, we need to have a ground plane. So let me create a ground plane real fast. There we go. Let me just center this bad boy into the scene. Fantastic. And of course, I also need to have, oops, excuse me, wrong button, a sphere. So we're going to do kind of the traditional bouncing ball exercise very quickly here in Modo. So I've jumped over into my, my animation window. All right, and I want to turn off the visibility of my lights and my cameras. So those little icons get out of the way. And I want to jump over into item mode. All right, and I want to start positioning this thing where I want it to go. Now, I know we did this a couple weeks ago, but today is just a kind of a refresher of the process. Okay, so I've gone ahead and I've established the starting pose for my character. What's the first thing that I need to do to my little bouncing ball up there?
Set it in the keyframe.
Got to set a keyframe, right? We need to make sure we have a keyframe on our object, and specifically the channels that we want to animate on frame 0 or frame 1, okay? Why? Why is this the first thing that we need to establish? It's the starting pose, absolutely. So it's an important element within the movement that we're trying to craft. And by initially starting with a keyframe, any additional change that we automatically make to that object is going to automatically be rekeyed. Okay? So it's critical, it's imperative that we get a keyframe down for all the channels that we're trying to animate on this object quickly. Okay? That way, the auto key can give us a hand. All right. So let's just do it real fast. I'm going to select, or just put keys on the X, Y, Z, or excuse me, the position, scale, and rotation channels on my little bad boy here. And let's start doing it. Let's start animating this thing. So on frame 0, that's where he's going to start. I'm just going to flush out my animation here real fast. And every 20 frames, I'm going to start placing a keyframe. So let's look at this thing from the, from the front. You can just barely see the plane, so I'll put the grid on so at least we have a little bit of a barometer and we can start animating. So on frame 20, I want this guy to be kind of whoop, down over there. Okay. Now on frame 40, I want him to be kind of maybe in here. Okay. And I'm just going to, what I'm doing is I'm blocking out the entire animation. I'm trying to establish the arc of our movement quickly. I'm not really paying attention to the timing yet. Don't care about that. I'm just trying to throw down some keyframes and block out the overall movement. And you can see here we get a tremendous amount of control as to where this object is going to be created and placed within the scene. If we play back our animation, it's award-winning. Awesome. Okay, but at the very least, it allows me to very quickly get an understanding of the movement of this character. Okay. One thing, and this is something that's new inside of Modo 701. It made a small little appearance in 601, but these motion paths are really rad. Did I talk about motion paths before? Right now, it's very difficult to get a really solid understanding as to where our ball is bouncing within the frame, right? It's hard to conceptualize its actual path that it's following, okay? Well, if we have our object selected, this motion path little menu here plays a much more active role. Let me show you what I'm talking about. I'm going to grab it. I'm going to go into motion path and check it out. I'm going to add a motion path. Aha! Check this action out. Now, check it out. It's showing us the path that our little bouncing ball is going on, which is very cool. Now we can begin to visualize precisely what this animation should look like. You also get some options inside this motion path. So I went motion path, and then I added a motion path. Okay? So what we want to do is that we maybe want to increase the range of frames that we're previewing, because if you look carefully here, check it out. We're not seeing the entire motion path. We're really only seeing 48 frames right around that element. So if we increase these values to Oh, I don't know. Maybe let's do 70 by 70. There we go. Now we're seeing a much larger picture of what this animation is. We're seeing almost the entirety of this motion path. Okay. You could, if you want, what you're kind of establishing here is the start and the end of your motion path in frames. So if I wanted my motion path to begin on frame 1, boom, and then I can end on frame 120, now we should see everything. Yeah, now we should see everything because we're seeing, oops, helps if I select it. There we go. So there's the entire motion path. Let's put this back to 70. Yeah. So really what's important for me to see the entirety of the motion path is this timeout. If you put them at both, let's see, if you put 120 at both, then it should stay on there, yep, until you get over 120. All right. Okay, so this is all well and good. We're starting to get a nice visual representation of the path that our ball is going along. But at the moment, you know, these little keyframe indicators really they're cool. I mean, they're useful. They're giving us an example of what it should look like. But I want to be able to go in and select them. I want to be able to go in and edit this motion path to create a more compelling animation. Well, we can do that by going back into our motion path menu and choosing Edit Motion Path. Okay. Now, all of these keyframe indicators do this, which is cool. And we can change precisely where they need to be inside of our animation. So this is, as an animator, this is precisely what I want, because now I can very quickly go in and control how and where all of my keyframes are being placed spatially within the scene, which is pretty neat. Okay. Now, you got to be a little bit cautious when using these action handles. They are going to change things in here, but be careful, okay? Be careful. Sometimes you'll get a really weird, wacky result, and the reason why I'm just imploring you to be careful because you're actually changing the incoming and outgoing slope of that object. Right now, I can't break them. I can move both of these tangent handles in conjunction with each other, but I really can't break them. You can set up your animation to do that on a per keyframe level. We'll come back to that in a minute. So I'm just going to change the incoming outgoing slope. Yeah, Chevy, go ahead. That's where we need to go to change, you know, to break the handles is inside the graph editor. We'll talk about that. Boom. Woo. Now we're getting some really nice arcs. Now help me out. Let's decode kind of what the computer is giving us on screen right now. We see the little green motion path. What do each one of those little dots along the motion path represent? A frame, okay? So watch what happens to those indicators as I start to move the keyframes in the dope sheet down below, okay? Modo is going to update your motion path and give you a really nice visual set of feedback on how, on the spacing in between frames, okay? So here's keyframe 1, so this guy over here. This is keyframe 2, so that one. I want to change the spacing between keyframe number 2 and number 3. Check it out. See how they're changing on this side? Now the movement between keyframe number 2 and that one, it's only happening in a couple frames. So that's really cool. That's really cool. I like having that visual feedback because now we can get a really good sense of where these frames are being placed within our animation. All right. Let's see if we can go in and continue to edit this and get a more compelling result because it's really not that realistic at all. If we were to play our animation, what's happening here? Yeah, so what isn't there? From an artistic perspective, what haven't we done yet? Weight. We have no illusion of weight yet, okay? And if you look at the way the keyframes are spaced in the animation, it's no surprise that we really haven't done a great job of establishing any illusion of weight. This is called a linear animation, when all the keyframes are evenly spaced. This doesn't happen out in reality, right? What should this animation look like? Where should the ball be moving the fastest And where should the ball be moving the slowest? Say again? Should be slower, right? Absolutely. At the top and the peaks of all of our arcs, the ball should be moving the slowest, right? Because as the ball travels up, gravity is going to start to pull that ball back down to Mother Earth, and then boom, it's going to go fast on the downward slope. So we need to go in and start to tweak all this. In addition, as the ball continues to bounce down its path, the energy that this ball is going to be using to do its motion is going to start to diminish. So it should start to move slower at the end. Fast movement at the beginning where there's a lot of energy, and then it's going to start to diminish towards the end. So we need to make some changes to the spacing of all of our keyframes to generate this result. All right. So let's go in. I'm going to stop my animation, and I'm going to go in and start messing around with some of these keyframes. Instead of maybe between here and there, let's start doing this by hand. Okay, so it goes, it bounces. So for the first bounce, let's define it as a 10-frame bounce. So it's going to take 10 frames to do its entire bounce. It's quick. Woo. It's awesome, by the way. So we have some work in here that we need to do. Okay, now I'm not looking so much. It's awesome. Let's do this. I want to select all 3 of these guys. Go. And really slow. So we need to definitely dump these down. For the second bounce, so there's the first keyframe of the second bounce. It needs to be slower, so let's make it a 15-frame bounce. Or excuse me, a 20-frame bounce. I apologize. So slightly slower. Oops, missed it. Now we're on our way. All right, so if you look at the animation, a little jerky here in the center, but that's easily fixed by going in and exploring the graph editor. This is the kind of the cool thing about having the dope sheet or the track editor right below our animation window, is that we could very easily and quickly move all of these keyframes around and continue to flush out the timing. However, we're not getting this first bounce is a disaster. It's a big disaster. Okay, there's only 5 frames that are determining the quality of the movement in this bounce. And if you look at the way that the keyframes have been established, there's an easing up here at the top that maybe we need to relax ever so slightly. This is where the graph editor comes in. We want to be able to use the graph editor to give us fine-tuned control over all the animations that we're crafting inside of Modo. We can get to our graph editor through a number of different locations. Probably the easiest way to get to the graph editor is to hit this button right here. It's going to extend the graph editor, and there it is. Here are all the function curves that are ultimately determining the movement of this object. Now, for most people, working with the graph editor is just a gigantic mess. They don't understand precisely what the computer is going through and doing inside of this really weird conceptual environment. But help us out. What specifically is the computer doing here? What are we seeing with all these squiggly lines down in the graph editor? They're called function curves, absolutely, but you got it. You got it. Now we're starting to see the animation system underneath the hood. These little graphs really are what driving the movement of this object. What we're seeing here is position plotted against time. So we have a graph. Let's talk about, or maybe what we should say is that it's a value plotted against time, because we can plot many different elements within this environment. So if we look carefully at the graph we have downstairs, check it out. So we have 2 different axes. The y-axis is value. And you can see that with the position channel, what we're establishing is feet, okay? An actual position within the scene. And then we're plotting the x-axis in the graph editor is time. These curve represents the transitioning in value across time. So if you look carefully here, this red line represents the change in value on the x position, okay? And it's got a really weird dip here, and then it very quickly goes into that keyframe. All the little white dots are keyframes. So we need to change some things in here. This is where being able to change the tangent handles, all of these guys in the graph editor, comes into play. Okay, I want to do this. In order to change all of the tangent handles for our keyframes and to continue to affect the curve that we're creating, okay, now also you can see that the motion path is changing there. So I don't necessarily want to change that one. I'm going to select some keyframes, and I'm going to ask the computer to perform a number of different operations for us. All of these buttons to the right of the graph editor will allow you to globally change how your function curve is automatically or how your function curve is created. There's some automatic functions up towards the top that allow us to change the slope of ours. But then these down here at the bottom are going to give us a little bit more granularity and allow us to customize specifically how those function curves are drawn by controlling each of the tangent handles independently. For example, I have this first keyframe selected, and if I just do an auto curve, that's the result that we get. This next one is, what is it? Manual slope. There we go. It's really this one here that needs all the love. So let's go ahead and start messing around with that one. Yeah, the auto is a good one to work with. And now we're starting to flush out. How all of these tangent handles are going to perform. I'll tell you what. I want to just zoom out here real quick, and I want to select all of these keyframes. Okay, and let's just do an auto. That way, it's a little bit more even. Now, auto is a fun one to work with because it just is going to smooth out all of our function curves and give us a pretty good result. But if we keep examining the details of all of these function curves, we can really zero in on which elements in the scene that we need to change. Okay? For example, position Y, the up and down movement of my sphere, is really the one that we need to focus on the most, right? We don't want to change the left-right positioning, which is the X. We need to influence the speed in which the computer is going to transition this element going up and down, because that's gravity, is that up and down movement. Okay, so we're going to focus on this one a little bit more, and you can already start to see the curve of your ball showing up in the graph editor. I want to change this a little bit. I want to change this a lot, actually. I want to be able to have the speed in which this guy is coming down and then back up at this moment in time be different. It should look more like a spike, right? If you look carefully, we're getting kind of this ice skating effect down towards the bottom. And a lot of that has to do with the tangency of the slope at this moment in time. So check it out. We can actually break. I want to control each side of my slope independently from each other. Okay? I don't want the handles to behave like this. Okay? I want to be able to go in and change the slope. So let's just do it real fast. You can do that pretty quickly by going over here, and this is the linear slope, if I remember correctly. We want to break all of our tangent handles. Stepped, linear. There's flat. Flat's a good one. Flat's a nice one because it's just going to flatten out the tangent handles. Boom, like that. Kind of cool. But we want to break all this. Here we go. So let's break the values. And now we should be able to, why didn't that work? What was I on? The slope is on manual. Oh, I'm sorry. Yeah, I hit the wrong one. Thank you. Absolutely. So we want to break the slope, and now we can control them kind of independently from each other. Well, we have to break each side of the slope because we have the outgoing slope, then we also have the incoming slope. So let's break this one. Now, maybe. Oops, don't want to move that in time. What just happened here? Let's unify everything. We go back in time. I'm hitting undo. This changed, the behavior changed. There we go. Unexpectedly. Come on, fingers and mouse. There we go. Yeah, I think that may be it. There it is. Thank you. That's what I was after. So we got to break the slope and then break the weight. Just break everything. I like that. Let's just break that. We'll break that. We'll break that one. That one's already broken. And now we can go in and completely adjust the slope here. Okay. All right. So let's see here. Let's do this one as well. We're going to create some really cool arcs. All right. This one we're going to break the weights. Going to break the slopes so we can control each one independently. And what I'm trying to do for the keyframes at the bottom of our arc is create more of a point. There we go. And this one, you can almost kind of see in the slope itself precisely where we need to have all these elements to get, or where we need to have these keyframes to get the result that we're after. Okay, cool. Let's check out our animation now. And I think I accidentally added another keyframe in there. That's all right. Let's play the animation. Yeah, timing's a little off still, but we're getting there. We're getting there. Yeah. I love it. It's subtle, but it is moving slower at the top of the arc, which is precisely what we need to do. If you look at the position X, there's also some opportunities in here for us to go in and change when and how fast these elements are moving between each other. Okay. The graph editor gives us a tremendous amount of control over how these elements need to be, the speed in which we're transitioning between all of these elements. Okay. We're going to talk a little bit more about the graph editor as we continue to go on. There's some additional awesome things in here that will allow us to very quickly get the results, the high quality results that we want. I wanted to do this just to kind of show you the process that traditional keyframe animators have to go through in order to get a compelling result, right? Tremendous amount of work just to get a silly ball to bounce twice and recreate the illusion of gravity. And we haven't even done the full thing. We haven't done rotation. We haven't created the illusion of squash and stretch. There's a lot of additional traditional animation features that we still need to go in to make this look cool, to make it look compelling, and to achieve that illusion of life. To make a simple ball bouncing across the screen, that's going to take us an hour, hour and a half, depending on the animator. It's crazy, right? That's a tremendous amount of work just to get a ball bouncing across the screen, right? I give a lot of respect and love to our traditional keyframe animators because they work in an environment and within an art form that at times incredibly tedious, okay? It can be a little bit of a challenge. Tests your patience almost at every single level. It really does, okay? All right. So let's talk about the alternative to this. We're going to do the exact same example, but this time we're going to work with it inside the lens of a dynamic simulation. Dynamic simulations inside of Modo will allow us to create global parameters, where each one of these parameters is going to affect a certain element within the scene. I'm going to kind of basically start over to a certain degree and continue to explore this idea through a new project file. All right, I'm going to have kind of a very consistent result. There's my little plane. I want to make it bigger. I'm going to make, come on fingers. Oops. There we go. There we go. Okay, so there's going to be the ground. And shoot, while I'm at it, let's just add a sphere in there. And when we compare the size of the plane to the size of the sphere, we need to make the plane much bigger. Excellent. Okay. All right. So now that we have our elements already established, let's organize our item list a little bit. I'm going to rename a couple elements just to make things easier for us to consume. So this is going to be the ground. And I'll name my sphere item ball just so we got things dialed in where we needed to go. All right. In order for us to set up dynamic simulations, we're not going to go into the Animate tab. We're going to go back into the Setup tab. And I understand that maybe could cause a certain amount of confusion because we've been looking at the Setup tab through the lens of rigging over the past 2 or 3 weeks. Well, the Setup tab has a lot of extra awesomeness inside that work environment, including all of the basic functionality for us to very quickly establish these dynamic simulations. All right, so let's go over to Setup and start rocking and a rolling. So now I'm in Setup. FYI, if you see your schematic window down below, you can actually turn that off for the time being, either by docking it down there like that, or by hitting this little arrow. This little arrow inside of your OpenGL viewport. It's going to maximize the viewport and just basically get rid of schematic, okay? But remember that you've done this, okay? That little yellow arrow is easy, easy, easy peasy to miss. Maximizing your viewport is, well, this implementation of maximizing your viewport is kind of wonky. I'm not a fan of it. I used to like it in the good old 601 days. They've changed its behavior, and it's just weird. Okay. So let's talk about what we need to do to set up our dynamic simulations. Okay. In order for this entire animation to be thrown out correctly, there is a certain number of new elements and new tags that we have to associate with these objects within the scene. Now, as a reminder, what we're trying to craft here is an animation where our little ball is going to bounce. Okay, it's going to bounce down, kind of like what we had before. All right. So let's set up the key pose. Let's set up where we want our ball to initially start, just like we did on the last one. All of this has to be done in item mode, by the way. Okay? Whenever we're animating, we're never animating components. And this is something that will blow up in your face if you're not watching carefully. Okay? Especially when you're starting to add these dynamic simulation tags to the elements in our scene. Item mode, item mode, item mode. Okay? I'm in item mode, so let me just use the item transform tool and get this element where I need it to go within the scene. And I want my ball to start somewhere right over here, kind of very similar to what we had earlier. Turn off my lights and my cameras, clean up my viewport a little bit, and now we're ready to go. All right. If you look carefully inside of your setup toolbar on the left-hand side of the screen, of course, we have a whole series of vertical tabs that filters out all the tools into their respective areas. Where we're going to be hanging out for the remainder of the day is in this Dynamics tab. This Dynamics tab. Now, if you've explored this feature in 601, this used to be called Recoil. Okay, they've renamed it. Now it's Dynamics. So if you're coming from the good old 601 day, it's Dynamics. Dynamics. And the most important part for the moment inside the Dynamics section is this top bit, all the blue ones. In order for our dynamic simulations to affect our scene, we have to assign certain roles to certain items within the scene itself. Okay, the ones that we're going to be focusing on today are active rigid body, passive rigid body, and soft body. Soft body, I'm just going to demo and kind of tease you. Next week, we're going to talk about its role a little bit more in depth next week, but I want to at least kind of illustrate the idea and the concept. Okay. The active rigid body and the passive rigid body system are going to be influenced by gravity. Okay? By gravity. But how they're influenced by gravity, and specifically what's going to move, is the difference between the active rigid body in the passive rigid bodies. So before we begin, we kind of have to do a little detective work and figure out what we want to move and what we want to remain static. Okay? What do we want to have move in our little scene here? The ball. Okay? What's going to be static, a non-moving element? The ground. Okay? Non-moving elements are going to be passive rigid bodies. They're still going to understand the role of gravity, but they're going to be kind of an influencer in the scene. They're not what's being influenced. Okay? We still want the ball to interact with our ground, so we have to have it as a passive rigid body. Anything that we want to move and we want to bounce and to be, an active member of our scene, if you think of it that way, it's going to be an active rigid body. So these are the moving elements. These are the things that are physically going to be influenced by the impulse values, fall-offs, forces, things like that. Okay? So the things that are static, passive. Things that aren't going to move, like set pieces, passive. Things that are going to move, active. Okay? We can mix and match as many of these in our scenes as we want, but it's something that you have to define before the rest of this entire thing happens. Okay? I'm going to select my bouncing ball, and I'm going to apply the active rigid body tag to it. So I'm in item mode, select my ball, there we go. And I want to apply the active rigid body tag. Now there's two things that happen the moment you click on that active rigid body tag. And both of them happen over in the item list. Let's check it out. We have a new element, a new player within our scene. This is the engine, if you will, of the dynamic simulation world, the solver. It's doing all the heavy lifting. This is the element that defines the role of gravity within our dynamic simulation. It's an important element, okay? It's a critical element. If we select it and look at all of its properties, you can start to see its role come to light, okay? There's two things that we want to look at here inside of the solver properties. The first one is gravity, and if you look very carefully, it's set to negative 9.81, I think, newtons, I think, is the unit of measurement, or whatever it is. I don't remember. This is the precise amount of gravity that good old Mother Earth is influencing and pushing down on all the objects here, okay? So we are, in many ways, recreating precisely, as best as the computer can, how gravity influences objects here on Earth, okay? You're free to monkey around and change that. It's just a value, but negative 9.81 is the default. This is how much gravity is pulling on our objects here on Earth. Steps. This is going to change the quality of your animation, okay? If you think about it, each frame, the computer is running a calculation, okay? It's asking the entire simulation, how fast am I moving? Am I rotating? Did I just bump into something? It's asking a whole series of questions each frame, okay? Think of steps, like how many times the computer is asking a question. So every frame is asking 5 questions, okay? And it's going to get 5 answers to all of those questions. If we want a more accurate recreation of our simulation, so if we want really fine-tuned movements or really precise movements, we have to give the simulation more information, right? We have to physically tell it to ask more questions and get more data to make its movements. So increasing the steps is going to give you a more precise movement, a more accurate recreation of the movement within the scene. But what is the big con here? Performance. Okay, it's going to take longer for the computer to figure out how to make everything move. So it's a give and a take. We get some accuracy, but it's going to take some time to cache and simulate all these objects. We're going to leave it at 5 pretty much for the rest of the day. Okay, but just know that that's where you can increase the quality of your simulation. Visualize, we're not really going to touch that. Okay, that's really for advanced users that need to debug and figure out precisely what's going on in this crazy simulation. Advanced, we're going to talk about at the very end of the day. So we're going to come back to that much later because it's super cool. I mean, it really is kind of cool. So you guys will dig it. And I'll show you a really great example of where we would want to use that advanced feature much later on in today's conversation. All right, so that's the solver. It's the global operator within our scene that's basically infusing gravity. This solver is going to influence any item, any and all item, that has a dynamic simulation tag associated with it, right? Associated with it. Which item in our scene has a dynamic simulation tag? The ball. So it's only really influencing the ball at the moment. The plane, because it hasn't been tagged, isn't going to be affected by it. Let me show you what I'm talking about. The ball is the only thing that's been tagged, so the solver is really only talking directly to that ball. If I start my sim, woo, there goes my ball. Okay. The plane didn't move. The plane didn't move because it isn't part of the simulation. The solver isn't speaking to it yet. Okay. Let's talk about the ball and talk about what that active rigid body tag has done, because it's kind of hidden, and this may be a fault of Luxology. I don't know. I'm kind of on the fence as to how they're communicating all of this dynamic information on the item level. But if we were to select our ball, check it out. We're going to have a new tab inside of our properties. So here's our ball. If we go down to our properties, check it out. We have a new tab, this dynamic tab. Inside this dynamic tab are all the parameters that's going to define the dynamic qualities of this element, including how heavy it is, how sticky it is, if it's smooth surface or if it's a rough surface, things like that. How bouncy this object is. Okay? We're going to come back to these parameters a little bit later. Okay? But that dynamic tab is where we find and control the specifics on this item. Okay? We're going to be coming in and out of this tab a lot. Okay? So get used to coming here inside of the item. All right? Now, one thing that I want to draw focus to before we go too much further, oops, excuse me, is the type. When we added, see that type value there? When we added an active rigid body tag, we basically changed the dynamic type of this item to dynamic. Okay? If you look at that pull-down menu, we actually have three options in here. We have dynamic, kinematic, and soft body. Okay? Dynamic is a fancy word for active rigid body. Kinematic is a fancy word for passive rigid body. And of course, soft body has the same terminology as the button you'll press over in the toolbar. Okay? It's important to recognize these differences. It's important to recognize that we can change them. So if you accidentally screw up, we don't have to retag them. We can just change their role within our simulation by going into this menu. Okay? Kind of make sense? Kind of make sense? Okay. Now that we have some idea of some of the moving parts inside of our simulation, let's talk about how we can simulate our entire scene. If we were to just hit the play button, okay, if you look down at the bottom here, of course we have our standard animation timeline controls. However, if we were to hit the play button, there we go, ain't nothing going to happen, okay? Bummer. In order for us to see the simulation to take place in front of us on the screen, we have to explore a new part of this little timeline down here, okay, at the bottom of the Setup tab. These three buttons will allow us to dynamically simulate our environment, okay, to have the illusion of gravity or the forces of gravity start influencing our scene. Let's talk about these three buttons, as this is a big change and a huge departure from what they established in 601. There used to be 2 buttons. Now there is 3 buttons. And I'm sure you guys are like, why is there 3? Why'd they add a new one? Yeah, well, I'll show you the differences between them. Okay. The first one, so the little play button that's got a hollow interior, this one, is going to dynamically simulate your entire scene forever. This is the live simulation mode. Okay, and I think it's best let me just do it real fast. I'm going to dock my playhead back at frame 1 here and hit the button. And woo! There goes our ball. Okay? And it's just, now our scene is live. It's not recognizing the total duration of our sequence anymore. It's an infinite live preview button of your scene. Okay? Notice that the playhead isn't moving from its original location. It's always going to be there on frame 1. The simulation is still going, by the way. Still going, it's still on. If I was to orbit my camera down, we'd probably see a little dot that would be my sphere, and it's just going to fall forever and ever and ever and ever and ever. Okay? So you're probably wondering why. Why is this important? Why is this valuable? Why do we want to have this? Well, when we start in a couple weeks, we're going to dig into particles in a big way. Let me show you why, just say why that button is important, and kind of give you a little preview of what we're going to be talking about in the next couple of weeks when it comes to particles. Particles or adjusting particle simulations is kind of a tricky little beast, okay? So I just added a particle emitter within our scene, and if I hit the play button, you can see that particles are being emitted inside of my scene, okay? Oftentimes, making changes to your particle simulations can be a little bit of a challenge when you're only working with 120 frames in your timeline. We want to be able to see how our particle simulations are going to be in effect on frame 800 or 900. So having this live environment is pretty cool. In addition, this live environment also gives us the ability to make some changes. Okay? For example, maybe I want to have the cone angle of this bad boy be slightly different. Maybe I only want my particles to be emitted up there. And you can see that that effect has happened live. I didn't have to restart the sim. It's a live mode. Well, maybe I want to have like a fire hose of particles coming out of my emitter. Well, changing the emission rate up to something really kind of crazy, you can see what happens. Okay? In addition, you can also rotate it, and it will update, which is kind of cool. It is. Or it's one of the things that they can use for rain. if you wanted to make it look like rain, and this isn't something I was going to really kind of focus on, let's just use gravity. And for something like this, I think I have to stop the sim and restart it again. There we go. There we go. We're going to have an entire conversation about particles. Okay, so I just wanted to show you the importance of having this live simulation mode inside of Modo. To answer your question, yes, it's going to show up, but there's some extra things that we have to add into our scene in order for it to render. Because if you think about it, particle is nothing more than a vertice, and you're not going to see a vert in a render at all. Okay, you don't see any of the vertices of your meshes when you render them out, so you're not going to see any of the particles. We have to add elements into the particle simulation in order for it to show in the render. And we're going to be talking about that in a couple of weeks as we start to apply volumetric effects, sprites. We'll do some blobby action, which will be kind of fun. We'll start to establish the underpinning of the fluid dynamic simulation here, which is kind of fun and very cool. So that's going to come in a couple of weeks. All right. Particles is really why we have that live simulation mode, because it allows us to work a little bit more interactively with the elements in the scene. All right, I want to hit undo for a second and just get back to my scene. There we go. All right. So the second button, the second button in our simulation tools, it's going to simulate the entire duration of our sequence. So the playhead's going to start here at frame 0, and then once it's going to go all the way over to 120. Once it gets there, it's just going to start over again. So we're really only going to see our simulation for the first 120 frames of our simulation. Okay, it's always going to restart as it hits the sequence end value. Okay, so that's what that one does. I can show you what that looks like. Boom. So there it is. The playhead's going. And then once it gets to 120, it's going to start over. Yeah. Okay. So the second button is going to give you a preview, okay? This is only a preview at this point of what the dynamic simulation is going to look like for the scene start and end values, okay? If I was to stop the scene, let's just stop it. If I was to stop the scene, or the sim, excuse me, and then scrub my playhead by left-clicking and dragging on the playhead in the timeline, what don't you see? The animation. Those first two buttons are previews. These are preview buttons. It doesn't actually save any of the simulation data into memory. That's what the third button does. Caches all of it. It saves all this information to the local, to your memory. Okay. When we hit that button, you're going to see a popover appear. This popover is going to allow you to determine which range of frames you want to cache. So I want the computer to simulate from starting on frame 0 and then end on frame 120. Now, because of the simplicity of my scene, you're not going to see the computer think at all. It's just going to pop in. Okay. On more complex scenes, you'll get a status bar, and it'll go tick, 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 as it's thinking, and because it's figuring out all the simulation data that's required within that range of frames. So you're not going to see it think at all probably here. Yep, it's just done. And then now, check it out. Now I'm just scrubbing to my timeline, and I can see the simulation or what the simulation is going to look like on each frame. Okay. One thing, however, okay, and this is an important note about that button. You are not permanently, this button does not permanently save your sim data. Okay. It's caching it temporarily. So what happens if Modo crashes? Or you quit your scene and go home? It's gone. All that sim data is gone, okay? We haven't generated any permanent keyframes. This is all temporary. I'm going to show you how to generate permanent keyframes later, okay? And we're going to bake our simulation to get permanent keyframes that we then can overkey and continue to massage and edit as we go, okay? So keep in mind that all three of these buttons are only really truly going to give you temporary sim data. This last one, most importantly, and this gets people all the time because they'll set up their sim. It's working fantastic. It's working perfectly here in the lab. They invest 20 minutes of calculation time on the computer to see what their simulation looks like. They're like, awesome, rock and roll. They save their project file. They go over to the lab, and none of their sim data is there. Okay? Because the moment you quit Modo, all that sim data is gone unless you bake it. Okay? So keep that in mind as you start to look forward to this week's homework assignment. Okay? Yes?
After you bake it, will you do to re-edit it?
Absolutely. Because what you get when you bake it are keyframes. And then you can go in and massage the data and continue to do what's called overkeying, which you're overwriting the simulation keyframes and creating your own, or editing the ones that are already there. That was loud. Austin's so excited about simulations. Okay, so let's make this something a little bit more compelling. We have a very simple example here, and none of the elements within our scene are really interacting with each other. I've already gone ahead and applied the active rigid body tag to my ball. Let's do the exact same thing for our ground. Dynamics, and we'll do active rigid body. Let's preview the sim. Whoa. A little bit of a problem here, right? Woo. Yeah, they're both falling. Why are they both falling? Because they're both active, right? They're both being influenced and pulled down by the illusion of gravity in the machine, right? We don't want the ground plane to be pulled down, but we still want it to be a participant, right? So what do I have to change here? What should the ground should have been? A static element, which is, what's the fancy word for static? Passive, okay? It's a passive rigid body. Now, I could go back and hit the undo key a couple times and remove the active rigid body tag and then replace it with the passive rigid body tag. But as a reminder, really what you're doing when you're changing from active to rigid body is changing the mode, or the type of dynamic simulation, or the type of tag that's been applied. So I'm on my ground mesh item. If I go into the dynamic tab, check it out. Changing the type from dynamic to kinematic is going to give us the result that we want. And I just saw a frustration, and I'm just going to, this is now, Katie threw her hands up, and, went, and I saw the Modo has crashed pop-up window appear on her screen. Before we get too much into it, save and save often, because you are asking your computer to do a tremendous amount of heavy lifting. The chances are good that my computer is going to crash here. So save and save often. I was doing some prep work before class today, and the values that I was inserting in a very particular part of the simulation was crashing Modo over and over and over again, and I didn't really think, or I didn't really discover what was going wrong until about 3 or 4 crashes into it. Okay, so save and save often. Okay, save and save often, because it crashes are going to happen. So by changing my dynamic tab from dynamic to kinematic, we're changing the role of the ground from being an active rigid body, dynamic, to a passive rigid body, kinematic. Okay? If we play our scene now, bong, woof. All right, mission accomplished. Now the ball is performing exactly how it needs to perform. Okay? However, we're not really gaining the compelling animation that we had created with our keyframes. It's pretty boring. Thunk. All right. So we need to go in and start changing some of the parameters of our dynamic tabs to give us the result that we want. Okay. Now that our scene is basically set up, we got to tweak the parameters, and this is the part of the dynamic simulation world that will make you go, because there's sometimes the small movements within these values will have a big effect on the animation that the sim is creating. This is a perfect time to save your project, okay? Because sometimes I've learned from experience when you're working with these properties, you can, it's going to crash. So I'll just do demo scene, or dynamics. Demo scene. I'll put it on my desktop. That way I don't have to reset and recreate my scene when Modo crashes. Okay. All right. So let's go and figure out what we need to change here to create the compelling result that we're after. I'm going to start by really focusing on the parameters of my little ball here. If I go into my Dynamic tab, there's really a couple things in here that we want to change and a couple elements that we want to focus almost all of our attention on. We want to focus on the bounce percentage, the friction percentage, and the mass percentage. Okay? Let's start with bounce and friction. Okay? Bounce and friction are basically going to determine kind of the surface characteristics of this object. Okay? In many ways, we have to figure out what type of movement we want this sim to create. I want to try to simulate kind of like those red rubber dodgeballs that I used to get pelted with in grade school. I was always the smallest guy, you know, so I was like the easy target. I was always picked last in dodgeball, and I was always out first. Anyways, so that's kind of what I want this sphere to behave with. So increasing the bounciness of our object is probably a good direction to go in. So at a bounce level of 35%, this is the result that we're getting. Let's run it. Bonk. Kind of doesn't really bounce all that much. There's a little bit of a bounce in there. Bump. And then it stops. Okay. So let's increase this. Let's increase it to a value of 100%. And see, oh, not 1,000%. Excuse me. That's really going to make it bouncy. We'll run it again. Bong, bong, bong. Better, right? Definitely a better bounce. Bong, bong, bong. Okay. We're getting there. We're getting there. Let's increase it even more. Let's put it to 300%. Boom. There we go. Shoot, let's do the live sim mode. See what we get. Boom. Boom. Awesome. Pretty cool. And it's just going to sit there and bounce for pretty much ever. And actually, it's getting higher and higher. How awesome is that? That totally makes sense, right? Who's taking a physics class in here? What's happening? What's happening here? No, seriously, this is the live simulation mode in action, and this is the real-world physics. The force is increasing. The higher it bounces, right, the more potential energy it's gaining as it reaches the top of the arc. Then as it's falling, more kinetic energy is being applied, and now it's bounced so far out. There it is. Woo! There it is. So each bounce, it's getting larger and larger and larger and larger and larger, right? Not exactly, the result that we want. Okay, and usually you get really funky results like this when you start to have your bounciness rate go over 100%. Okay, try to keep everything under 100% for the most realistic recreation of the results that we're after. Okay, so this is where it gets kind of crazy a little bit because we have to adjust a number of different parameters here. We have to adjust the bounciness, the friction, and the mass on both the ground and the ball to give us the results that we want. Okay, we're physically creating surface characteristics, physical surface characteristics of these objects to generate a result. So there's a lot of tweaking that we're going to have to do to get these simulations dialed where we want them to go. There's always going to be a relationship between the elements in the scene and their interaction. Okay, let me dump down my bounciness to 100%. There we go. Let's run the sim again. Okay. All right. Oops. Let's talk about what in the world friction is all about, because friction actually has a large role in the scene that we're creating here. Friction, think of it kind of like sandpaper. Okay, think of it like sandpaper. When we have a friction value of 0%, the surface of our ball is offering no resistance to any other surface that it interacts with. Okay, it's going to be very smooth, if you will. If we increase it to something that's very high, it's going to act like sandpaper, where it's going to start to grab and stick on that object as it continues to move. Okay, this is going to have an effect on the illusion that we create. Let's dump it down. Sometimes the effect is really small, and you don't necessarily see it with the parameters that are applied to the scene. So with our ball just kind of dropping straight down, really didn't do anything. Really didn't do anything. You'll see this in action here in a minute when we start to move our ball forward and have it be influenced by a force. Okay? So think of the friction like resistance. At a value of 100%, oops, excuse me, at a value of 100%, yeah, we're still getting the same bounce. Okay? So whenever I'm working with that friction value, I'm thinking, okay, is my ball like sandpaper at a value of 100%, or is it completely like glass at a value of 0%? Okay? Because our ground plane also has a certain percentage of friction for its own physical characteristics, it's influencing, our ground is kind of like sandpaper right now. So anything that touches it is going to stick a little bit. If I want everything to slide around like it's on ice, I've got to remove those values all the way down to 0. Okay? This is where the madness of dynamic simulations can really kind of bubble to the surface, because we have to really look at what we're trying to craft and change all of the values for all of the dynamically simulated elements to yield the result that we're after. Okay? So it takes a little bit of work. It's a different kind of work that we're used to playing with, but it's still some effort. Okay? All right. I'm going to put that friction value back down to 60% or so. There we go. And now I'm going to focus on the mass. And this is probably the parameter inside of our simulation that's the easiest to understand. This is just how heavy the object is. Okay? So if I wanted to create a bowling ball, I would obviously increase this weight pretty significantly. A kilogram, right now, my ball weighs a kilogram, which is like next to nothing. That's like how heavy a feather weighs. Okay? It's really, really light. Okay? Huh? Say again, I couldn't quite hear you. Yeah, it's somewhere right around there. It's what? 2 pounds. 1 kilogram is 2 pounds? Roughly. Yeah, so anyways. Google it, yeah. Figure out. I'm not a math teacher. All I know is that this needs to be heavier, okay? So if you think in the world of pounds, well, we can change that. We can enter that in. So maybe I want this thing to be like a 10 pounds, so I'll put 10 lb. Boom. It's 10 kilograms. Okay. No, it should have been lb. Why did it go to 10 lb? Okay. You can change your weight values by going into preferences. I might just be entering it in wrong. Yeah, here we go. Mass unit system. I want English. There we go. Pounds and ounces. Oh, I think maybe I should have written out pound instead of lb. Now, lbs. That's what it was. Okay. So now, there it is. And Katie was right, or she was very, very close. 1 kilogram is 2.2 pounds, or yeah, right around there. You were close. You were really close, actually. All right. So now this is 22 pounds. I don't want it to be 22 pounds. I want it to be 10. There we go. If I run the sim, boom, boom. Cool. Now it's going to start to behave kind of like a bowling ball. All right. So let's see what we have to do here to get to a little forward movement. Because right now, I want my ball to kind of bounce forward along the x-axis. So if you look carefully, we need to really understand which direction we want our element to go. Right now, my ball is placed in the positive area of the x-axis, right? I want it to move from the positive area of the x to the negative area of the x. Keep that in mind, okay? If I want to get my ball moving a little bit, I got to push it. I got to give it a little bit of impulse, okay? So if we go back into our dynamic tab, check it out. This impulse section is pretty rad. This impulse section is going to allow us to basically, kind of push our ball forward by a certain value. I drew focus to which direction we wanted to push this element a moment ago to have a better understanding of which value and which axis we need to push this element along, right? We're getting very specific here as to which way the force is going to be applied to our sphere. I want the ball to move from the right side of the screen to the left side of the screen along the x-axis. So what value am I going to put in there? A negative Newton, right? A negative force value. If I wanted to push it going the opposite direction, I give it a positive value. So the positive and negative values that we put in any of these, any of the impulse ones, so the torque and impulse, is going to determine which direction we're going to push that element within the scene. Okay? So I want to push this guy, I don't know, at some value. This is one of those things that you kind of have to figure out. Depending on your weight, let's see what happens now. Oops, my sim was running. So now I have 48 in there. Let's see what happens. Let's see what happens now. Not a single thing. Oh, it rolled a little bit. Okay. Let's really dump it up some. Now we're... Yes! That was awesome. There it goes! Whee! Okay. So what happened? It went the wrong direction. I wanted to go from the right to the left. I did positive values inside the impulse x. If I did a negative value inside the impulse x, we would have gotten the result that we want. Okay, so keep that in mind. Let's do negative, oh, excuse me, negative 40. There we go. Negative 40 newtons. Run the sim. Yeah. Woo. Let's bring that down a little bit. Let's bring it like down to negative 20. Oops, I'm going the wrong way. My mouse. Boom. Cool. And now it's just going to roll. Okay. So the impulse is going to determine the amount of force that's being pushed onto our object.
So is this like at the start of the simulation, there's a one-time force in which case then...
Poof. Yeah. You got it. You got it. It's like at the beginning of the scene, if I'm standing behind you, I'm pushing you once, and I'm forcing you to go forward. Not that I would push you.
Can we see it with the plane rotated a little?
Say again?
Can you rotate it?
Yeah, absolutely. You want me to rotate it like this? Oh, okay. Yeah, we'll come back to that. We'll come back to that. It's just going to roll off the end. I mean, that's all it's going to do. Okay. Okay, let's keep talking about impulse, and because there's a couple other things in here that we need to define. And I think the best way for me to describe this is, here we go, because there's two things in here on impulse that's important. So we have impulse, and then we have impulse position. Okay. The impulse position is going to define where on this ball the force is going to come from. Okay, so it's like where we're going to push it. Right now it's being pushed precisely in the center. What if I wanted to push it at the top? Okay, let's use a different example here. Instead of having a sphere, because we're really not going to see the change in impulse position on a sphere all that much, let's get rid of the sphere. Let's do a cube. Oops. Oh. There we go. There's a cube. Okay. Let's move this element where we need it to go. Let's put it kind of like over there. Okay, excellent. Let's make that an active rigid body. Let's test the sim. Aha, it works. Perfect. Okay. Let's give it a little bit of an impulse so it's being pushed forward. We did like negative 20. Now this is going to have a different effect because the weight of this is much, much different. Boof. Yeah. Let's make it 20 lbs's. There we go. Boom. Okay. Let's do 15. There we go. Okay. Now if you look very carefully at what's happening here, it's as if the object is being pressed perfectly in the center of its mass, right? Let's watch it again. Boom. What if I wanted to get kind of a spinny effect, right? If I change where the force is being applied within the scene, I can yield a much, much different result. Okay? It's kind of cool. Let's see if we can change that. Impulse position. Let's increase it on the Y a little bit. Yeah. Now it's being pushed up here. And this is all local to the size of the object itself. Okay? I know this is a 1 meter by 1 meter cube, So I put the impulse to the local, to pretty much the top corner here. If I do 0.5 meters, see what we get. Kind of the same result. Now it spins forward. Let's do 0.25 meters. Boom, not as much, okay? Because now at 0.25, it's like it's being pushed. If this is the center, of my cube, like right here, it's being pushed kind of like right around in here. When I have it at 0.5 or even above 0.5, it's like we're pushing just this top corner forward, and we're getting that spinning effect, okay? So this is where we're pushing the object in relationship to the object itself, okay? I'm just going to put that back to 0 and show you the result once more. Boom. Doesn't look like it's being pushed all that much, right? Okay. Pretty cool, huh? Pretty cool. I like it. I dig it. It's a lot of fun. Let's do 0.25 meters again. Boom. Pretty cool, huh? Okay. So we're pushing our object forward, or excuse me, along the negative x-axis. We're pushing it kind of towards the top of the object, which is making our box spin. But what if I wanted to spin like a top? What if I wanted to rotate it and have it spin like a top and then land on the ground and like that? Well, that's what torque impulse is going to do. Impulse, position, right? It's going to move it forward within the scene. Torque is going to allow it to spin. Okay. Now I want to spin it along the y-axis, so it's spinning like a top. So if I add some value in there, we can create something that's pretty rad. So let's do 20 newtons. See what we get. Here, I'll tell you what. I'm going to reduce my impulse position, and let's put this down to like 5 newtons because it looked like it was going like crazy. Yeah. See how you see how it was spinning initially? Check it out again. Without that in there, we just get this. Boom. So by having a value in the torque impulse, there it is. Pretty cool, huh? Pretty cool. So those are the impulse channels on our dynamic tab.
So I have a question. Since I'm fairly sure where I'm going with this. There are animated tabs on this, but it's a simulation. But they're animatable tabs.
Yeah. Let's explore this a little bit. Okay. Now for impulse, this is a one-time push, so we're never really going to be able to see the quality of that force being applied across time, right? Because that impulse value is only going to be fired on frame 1. So there's really nothing to animate there. However, there are some other parameters in that advanced section of the solver that's pretty rad. We're going to come back to that later. So we're going to come back to it. Okay. All right. Things are looking pretty good, but I want my little box to kind of slide along the ground plane a little bit. So help me out. What do I need to go change on the ground to make it like an ice skating rink? Friction. Let's go check it out. Let's go check it out. So this is where all those relationships between the dynamic elements really come in. Right now, the default friction value for my ground plane here is 60. Let's put it at 0. See what we get. Yeah, now it's ice skating, and it's just gonna fall off the edge. Ah! Lots of fun. That's pretty great. Also, if we were to increase the bounciness of this ground plane, what do you think is going to happen? So now we're dropping a rubber ball on a rubber surface. What's going to happen? It's going to bounce even higher. It's going to bounce even higher. So this is, again, an illustration of the importance of understanding that all of these elements are related to each other. All of these elements are passing forces between each other, and they're influencing each other. So if I put the bounciness of my ground plane up to 100, bong, 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 slightly different animation. Slightly different animation. Okay. All right. Let's add a third player into the mix here. Okay. Let's add another box. All right. Let's add another box. Okay, this is box numero dos. And I want to put this element kind of over here. I want to have this guy I'm also going to make it bigger, just so I can ensure that it is hit by, by this guy over there. All right, so let's make it an active rigid body, and I want it to be hit by that guy there. All right, so the active rigid body tag has been applied to it. Let's play the sim. Boom. Pretty cool, huh? Pretty cool. So we can continue to add in additional elements into the scene and have each one of these elements influence one another. Okay. Let me stop my sim here for a second. And I want to show you one of the really cool features about working inside of the Modo dynamic simulation world. I'm going to put that box over there, and I'm going to make its dynamic weight much, much higher than what it is. Let's make it 50 pounds. Okay. Let's see what that gets us. Let's preview the sim. It's just going to hang out, and then it rotates, and then boom. Not much love at all, okay? As it should, right? It's a box that weighs 50 pounds, so when a box that weighs 10 pounds runs into it, it shouldn't have too much movement on that side, okay? But what I wanted to show you guys is that these items can be duplicated. Instead of, maybe I want to have 3 gigantic wall boxes at the end there. Well, I don't have to make 3 sphere or 3 cubes and then apply the rigid body 3 times. When I duplicate that item, all of its dynamic properties are also duplicated. Okay, check this out. So cube, let's just rename this, I don't know, wall. Okay. So if I, let's just duplicate this guy. Or shoot, we can even just use our traditional cloning tools. Okay. I'm in item mode, select my item, can duplicate it. Let's just clone it. There we go. Oh, I don't want 7 of them. Maybe I just want 3 of them. And I don't want each one. Sure, I'll leave them each rotated 90 degrees. Let's rotate each one of them. Let's rotate each one of them 45 degrees. There we go. Cool. All right. So if we were to examine these other walls, check it out. They already have the exact same dynamic parameters of the one that I cloned it. All of those values have been retained, which is kind of nice, okay? And most specifically, you can see that by the mass. The original one I set to 50 pounds, and when I cloned that original one 3 times, they adopted that exact same value, okay? Now these are independent; they're not linked to each other in any way. So it's not like an instance where these things are referencing one another. These are still independent objects, and I can control them independently within my scene. Okay, check it out. So let's run the sim now. See what we get. Keep your fingers crossed. They all fall on top of each other. Boom. Excellent. Okay, let's try this. I'm going to do this. I'm going to select all 4 of these guys, and I don't want them to be 50 pounds. Okay, I want them to be 10 pounds. You can also update a whole series of selected dynamic items at the exact same time. So maybe I want them to be 10 pounds. I don't have to do each one individually. I can do them globally. Huh? Make them what? 5 pounds? Yeah, I can do that. Select them all in the scene. Go to my dynamic tab. Make them 5 pounds. See what happens. Uh-oh. And then, there they go. They're still falling. They'll fall forever. All right. Pretty cool, huh? Pretty cool. Okay. I'm going to make each one of these incredibly bouncy. Incredibly bouncy. Let's just do it real fast. Let's put their bounce value to 100%. Okay. Awesome. Okay. That'll do. That'll do. Okay. And let's put their friction. Let's put their friction up. So when they touch each other, they should be pretty sticky. Yeah. Okay. So their bouncing is way too much. So let's put that back down to 60. I'm trying to recreate something here. You know what? What I'm trying to recreate may be better illustrated if these elements were small. Okay. So here's what I'm going to do. I'm going to make I want to make another little box. Okay. However, I want to make this box very, very small. I want to make it small, and I'll make it kind of long like that. There we go. Excellent. Let's make it a dynamic object. If I apply the tag before I clone it, that tag will be preserved. Let's move it up a little bit. Excellent. Okay. And now let's move it into position. Okay. Now I'm going to clone it. I'm going to clone it in item mode, model tool, duplication. Let's do the clone. And this time I don't want it to rotate 45 degrees after every copy. I just want a whole series of them like this. You can see that there's a very small space between them. Let's see if we can get them kind of close to what we want. If I remember the parameters, the size of it, I could have done it numerically. And I'll just make a whole bunch of them like that. Let's see. There we go. Okay. Excellent. Let's run the sim now. Let's see what we get. Uh-oh. It's wobbly. It's wobbling. Whee! Okay. So we have a little bit of a problem here. If you watch, let's change the weight of these. Let's increase their weight. And shoot, let's just do it this way. You can use the item list. Oops, excuse me. There we go. Let's go to their dynamic tab. Let's make them 10 pounds. Let's run the sim, see what we get. Okay. Now they're kind of wobbling there, aren't they? And then boom. Awesome. Looking good. Okay. Let's talk about an important idea. Okay? Because I don't want any of these elements to move for some time. If we look at the sim at the moment, they fall, and then they're wobbling there, and then I want them to be completely static for some time, okay? I don't want to see them fall and wobble all around. I want to turn when their dynamic simulation tag is going to become active. And this is kind of one of the cool things about the Modo dynamic system, is that we can apply all these dynamics and then control when they're going to start, okay? When they're going to begin to be evaluated within the scene. Because I only really want them to move until they're hit by that cube. Okay? That's the only time I want them to be hit. So let me show you a couple different options in here that will allow us to do that pretty easily and very quickly. Okay? All right. So there's all my cubes. And if we examine, I want to select all of them. There we go. So I can do them together. If we go to the bottom section of the dynamic tab, check it out. Of course, we have impulse. I don't want any impulse. But check out this sleep. And really, this is kind of it's really kind of labeled wrong, in my opinion, because we're not putting these things to sleep. We're waking them up, okay? Because then we also have deactivation down there. So it's kind of two different ideas. I get to control when this dynamic simulation, or excuse me, when these dynamic elements are going to be simulated inside of my scene. I don't want those cubes, those little stacks of cubes, to be simulated until a very important event. Okay? Right now, the wake on value is start. So the moment the scene starts, they're going to be dynamic. Okay? We saw that earlier. However, check out the other options within this list. It gives us some cool parameters to work around with. We have collision velocity, we have collision force, velocity, trigger at a specific frame, or at a very specific time. So if you're used to working within seconds, this will allow you to do that. I want to show you trigger, because trigger is kind of neat. Trigger in time or trigger in frame will allow us to have a tremendous amount of control as to when we want these elements to take place, or to when to begin their simulation, because not everything, I don't want everything to be firing off at the exact same time, okay? Because that could have an adverse effect on the results on the other end, okay? Trigger is kind of cool, okay? I like working with trigger, and notice that it is an animatable feature. Trigger is kind of an on-off thing, okay? So let's just put this thing where we want it to go. Let's see. I want to cache my simulation so that I can scrub through my timeline. There we go. Looks like it's done. Here comes the box. Then, oh, yeah. Because I'm using trigger, it's not being evaluated right now, but I'm using the animation of the cube, which should be pretty consistent to define when this element is going to be triggered. So maybe like right about there. Keyframe, trigger. Okay. Let's run the sim again. I'll cache the frames this time. Oops, I need to have an on-off value, I think. Oh, wait, excuse me. This is an on-off. On-off. So at a value of 0, the sim is off. On frame 94, I want it to be on, so I'll put the value to 1. Let's run the sim. See what we get. There we go. I may have done it backwards. Why is that not working? Trigger, because they both have a value of 1, because I'm a dork. Let's put that to 0. Why isn't it preserving that? Graph editor. Time to see what's going on here. I think you are absolutely correct. Let's open up the graph editor and explore. Oops, excuse me. Precisely what's going. Yes, okay, I get that. All right. Wake on. No, I don't want the wake on. Oh, yeah, I'm a dork. I'm keyframing the wrong thing. I always want it to be a trigger. I want to have at frame 93 the value be 0, frame 94 the value be 1.0. This requires an active tool. No, it doesn't. Wake on value. Yeah. Why is that not working? Okay. Let's change the value to 1.0. Ha! There we go. Now it should work. Should. That's a good sign. It's a good sign. Ah. Why isn't that working? That worked when I prepped. What am I missing here? Say again? Break time. Actually, it's actually not a bad idea. I've been yakking for almost 2 hours. Let's take a small break. Let's take a small break, okay? And I'll continue to explore why this is not working the way it should be working. Maybe it's because I'm trying to do it on a bazillion of them at once. Trigger. There we go. Yeah, I think I was just doing it wrong. I don't know why I the right channel wasn't selected. Okay, cool. Yeah. Okie dokie. All right, so I wanted to kind of show you some of the problems that I'm interfacing with here, and really why we want to go in and really start to dial in when these dynamically simulated objects are going to fire off and become active within the scene. So this is kind of right about the exact same thing that we saw before. Let's run the sim real fast. And look at these guys. See how they're just kind of jittering there? They're technically doing what they're supposed to be doing, right? I mean, if you look at the scene from the front, watch my little brick wall here. They're going to fall, and because there's a little bit of a gap between that bottom brick and the floor plane, they're going to fall, boom, and then they're just going to sit there and kind of jitter, especially that bottom one. Okay. Now, what I want to be able to go in and simulate is, well, I don't want that wall to jitter at all. I don't want it to move, and I don't want it to become a dynamically simulated element until I tell it to. And I got the trigger thing working, and it was all entirely my fault and my stupid butterfingers. I was keyframing the wrong thing. So I was in the right ballpark. Let me show you what I'm talking about. This trigger is going to tell the computer when these elements are going to turn on. So if we go back into our dynamic tab, there we go. So right now, the wake on has been changed from start to trigger, and its default value is 1.0, okay, which is what we want, okay? Let me go make sure that all of these other lovely fellows are at 1. Yup. Let's grab that one too, okay? And I'm going to cache my sim. That way I can figure out where inside of my range of frames right there. Okay, so on frame 95, I want these elements to become active. Okay, so at this point, they need to turn on, or the dynamic simulation needs to be applied to all of these cubes at this moment in time. So let's keyframe that value at 1.0. Now on the previous frame, I want these things to be off, right? So I really only want them to turn on over the course of one frame. So in essence, what we're crafting here is a light switch. We're flipping it on, or it's off, and then we're going to flip it on frame 95. This is something that you really only should do within a one frame kind of value on this thing, just like a light switch. So I'm going to go back one frame, okay, on frame 94, and put this value to 0. Okay. Now this is something that you're not going to see when you do the live sim, right? Because it's going and fail. Okay. So if we cache the sim and have the computer computate and figure out all this stuff, then check it out. Over here on frame 0, not moving, and then when I get to frame 95, boom, they're active and they go. Okay? So it's something you're only going to see when you cache the sim. That, I think, is a change, and I just wasn't aware of that change. Now that we're working in this live simulation world, I mean, things are different in the live sim world. Okay? I want to show you a couple other things in here that's really, really important to keep in mind. While you guys were on break, I went ahead and let's stop this. I added a small little cylinder into my scenes. Let me activate it, and I made it an active rigid body. However, check it out. It's sitting below my plane. Okay, so it's not on top of it like it was, like my bricks are over here. There's a gap between the ground plane, that element, and it's below it. Watch what happens. Watch what happens. Did you see that? Because it's below, the computer doesn't know what to do. It's trying to get it on top of that that passive rigid body. Boop. And it just pops right up, okay? And you can see that without caching all that information, we got a brick wall here. I just love it. Boop. All right, let's cache the sim. And then we'll play it. Oops, there it is. I was thinking about it. Still pops up. And then right at frame 95, everything turns on, and boom, and it's off. Okay. Now, we have some other really neat triggers inside of our system that will allow us to create some awesome, awesome effects. I love being able to turn on my dynamically simulated elements through that trigger, because now I'm in control, right? I'm in control as to when these things become active. Well, what if I don't want to necessarily go and keyframe that? keyframe the light switch. What if I want to have my cylinder turn its dynamic simulations when something touches it? Okay, we can do that. We can do that. Check it out. I'm going to go into my cylinder, select it, go into its dynamic tab, and now instead of having the sleep be start, I want to change the activation be a collision force. So when something runs into it, it's going to register that collision and turn my cylinder on. So with the value at start, oops, when it was on start, remember it popped up and was kind of jittering around on the surface. Let's cache the sim now and see what we get. There we go. Aha, look at this. Nothing happens. It's still existing below the ground plane. Okay. Let's watch it now. So if I play my animation, this isn't going to be turned on until it hits frame 95. And then boom, the moment something touches that cylinder, it's going to become active. Boom. And it's pushed out of the way. Let's make my let's change the settings of my sequence to be like 300 frames, so we can see more. So we can see more of my sim. We got to cache it in order for all this information to take place. Here we go. Let's play it. These are inactive, inactive, inactive. 95. Boom. Oops. Looks like I only cached. I forgot to increase this value here to 300. Pre-roll, so we can actually have the computer computate or figure out all the dynamic stuff before the frames start. Kind of much more important for particles, because if we have particles that are born before our sequence starts, we want to have all that information in the system already. Okay. There's the simulation. Now I'm simulate. Oh, sweet. Here comes the cube. Pretty cool, huh? All right. I want to start something else here. I'm going to get rid of basically everything except the ground. Delete everything. Go back to frame 1. And let's do this. I want to add in some spheres now. I want to make a rain. I want to drop a whole bunch of spheres on top of each other. So let's just do that. What am I doing here? There we go. Sphere. Let's make it an active rigid body. And I'm going to place this guy kind of up here. There we go. And let's do this. I want to make an array of them. I want to clone them, and I want to drop a whole bunch of spheres onto my little ground plane. Shoot, let's make my ground plane bigger. This is going to get kind of crazy here. There we go. All right. Let's just test the system, make sure it works. Oh, let's make it more fun than that. That's kind of dull and boring. Let's make you bouncy. Let's increase the bounciness to 100%. There we go. Doing. Okay, a little too bouncy. I did 60. Let's see what 60 gets us. Yeah. Let's do 90. Or let's split the difference. Let's do 75. There we go. That's kind of cool. All right. And let's give it a little bit of a torque, too, because I want it to kind of spin as it falls. So I want to give it a little bit of a torque, a little bit of an impulse torque on the z-axis. Let's do 10 newtons. Let's run it. Awesome. Cool. I did 10 newtons. That's might be too much. Let's do 5. It's half it. Still a lot. Let's do 1. Yeah. Awesome. And, excuse me, let's make it pretty sticky. Let's put the friction value up to 100. I'll do the same thing for the ground so that it kind of grabs the sphere. Cache all 300 frames. Let's see what the animation is. Oh, there we go. And now it grabbed the ground, and it went that way. Oops. Awesome. Huh? I did, what did I do? I'm sorry, I was distracted by the small little problem in my animation here. Woo! Got to figure that out. That's probably a steps thing. If I was to increase the steps in my solver, I would ask more questions between each frame, and it would probably figure out how to keep the sphere on the ground plane. Okay. I think the ground value I put up to 100% on the friction. Okay. So I'm going to duplicate this guy. I want to duplicate my little sphere because I want a whole bunch of these. And I'm going to do an array of them. An array, let's see, I don't want 6 by 6. I want, let's do 6 along the x, 6 along the z. There we go. As one would imagine, you can see the nightmare that is about to unfold here. It's going to be great. Space them out a little bit. It's going to be fantastic. Just wait. All right, I want to see if I can crash Moto. Because it's Friday. I'm in a good mood. Let's see what happens. All right. Yeah, time to save. Yeah. I'm also going to make my ground plane bigger. There we go. All right. This is something I'm definitely going to need to cache. And just let the computer think about it for a second. Oh, good. It's going pretty fast. Ha! Let's see what happens. Yeah, nothing. Awesome. Why didn't anything happen? Oh, I'm not in item mode. That's why. Why didn't any of that happen? That's interesting. It was working before. Oops, hit the wrong button. That's my fault. All right. Well, let's hit undo a couple times. See where the train derailed. You know, I might not have been in item mode when I did the array. No, I was. Interesting. All right, let's see what's happening now. I broke Moto. I told you I was going to break it. Let's see why I broke Moto. Yeah, I've lost all of my dynamicism on this object. Ah, somehow it got disabled. What? Did I do that? Okay. All right. Maybe I had some butterfingers. Accidentally turned it off. Let's try this again. Duplication. I'm in item mode. I'm going to do an array. Yeah, you know, it may have been the mouse. I may have had the cursor in the field, and I just accidentally scrolled with my mouse and just turned them off. That may have actually been what it was. All right, let's try it now. Simulating. Yeah, there we go. Oh, that's boring. Okay, so I got some things I need to change because that was boring and dull. You know what the problem is? Is that they're all falling, and the forces that are influencing their bounciness, I need to make them more bouncy. I need to make them more bouncy, and let's see. I got a lot of these spheres. Something maybe I should have done beforehand. Okay. Welcome to the world of simulations. We're setting up parameters. Let's make them much more bouncy, and let's give them some just random torques. Let's give a value of 1 on all 3 axes and see what we get. Now they're going to be spinning every which way. See what we get. They're all getting the same thing. Although it is incredibly entertaining. There we go. There we go. Okay, so I have an idea. Of what we can do to make this a little bit more interesting. I'm going to select entire rows here. Let's do this. Don't want you. You're out of the club. Let's do this. I want to move you. Oops. I want to move you guys up and over. Yeah, now we're talking. Now we're cooking with steam here. Let's do this. see if we can make something that's kind of rad. This is going to be awesome. I might have to make the ground plane bigger, yeah. Let's do this. Let's put this one over in here. There we go. Now let's see what chaos ensues. So you kind of have to be like half evil genius to do this, because you really are you're just setting up parameters for your scene to take place. Okay, let's see what we got now. Let's cache the sim. It's probably going to take a little bit longer now to figure out all the... Okay, here we go. Boom. Awesome. I love it. I love it. Let's see if we can randomize it a little bit, because it looked as though it's pretty uniform. That's cool. Each row is kind of working independently from each other.
Can you change the ground plane so it's like a fall off so it affects different areas?
Yes, I can. Let's see, maybe, let's go into the ground plane. I want to change the bounciness of the ground plane down to 0. Let's see what happens when we do that. It may be the ground plane. Oh, taking longer to sim this time. That's always a good thing. There we go. That's at least a little bit cooler. Okay, what I wanted to show you guys was the power. I love it. The power of this solver. This solver can do some really cool things. Now, earlier I mentioned that we were going to explore this global operator, our solver, in a little bit more detail. Of course, you know, the steps is going to increase the quality. This is going to be how much force is applied to our scene. What I want to go in and do is start talking about some of the roles of some of these advanced features. Okay, specifically, there's one feature in here that's pretty neat, and I like it a lot, and it's the time scale. Okay. I can change how time is affected, or how time is affecting all of my dynamically simulated objects within the scene. Okay? It's pretty cool. Notice that it has a value of a percentage, and it can be animated. Okay, oops. All right, so let me figure out where inside my sim. So, okay, so this is kind of... I'm still hating this. Oh, this is driving me crazy. Okay, I have an idea. This will be the last thing I change, I promise. Okay. I promise this is the last thing I'm going to change. Instead of making an array, what I'm going to do is I'm just going to clone them vertically. I have a whole bunch of these. Okay, let's try that. See what we get. Cool. Yeah. It's awesome. I love how it actually, if you look carefully, the force goes up the chain. They start bouncing up because the ones at the top. Hey, let's make them all real heavy. Sorry, I know that I said I was going to do the last thing, but I'm just like a kid in a candy store here. I just want to play with my toy. Let's make them all like 50 pounds. See what happens. See if how it changes the sim. So now we have a whole bunch of really, really heavy bowling balls that are kind of bouncy. Yeah, that was not the result I wanted. Okay, so maybe they're too heavy. Let's try 1 pound. Oh, here we go. Here we go. That's awesome. Yeah, I also have that rotation going, but that's okay. I'm just trying to create a little bit of chaos. Boom. Here, I'll tell you what. I'm going to grab maybe like the top 5, and I'll just move them. moving that way. Yeah, that scatter clone will work fine. I'm just trying to get a very specific, there we go. Okay, that's good enough. I'm just trying to get a very specific kind of movement to illustrate this next piece. Okay, perfect. Perfect. Okay, because now, if you look at the animation that we have, they bounce, and then they're all kind of bouncing each other. Okay. What if I wanted to stop time? What if I wanted to make like this really cool, like matrix bullet time effect? Okay. Yeah. Okay, check this action out. It's pretty cool. Let's do this. I'm going to have a bullet time effect because I want to have it because I think it's rad. So we're going to kind of use some of the skills that we've been talking about the last couple weeks. I want to make a path. Let's just do a Hermit Curve. And this is going to be the path that's going to define my camera movement. So in the Matrix films, they had the camera kind of zipping around in an arc. There's my path. Excellent. Love it. Let's kind of put it at a cool height. I don't want my camera to be right on the ground. I want it to be kind of in the middle of the chaos. Awesome. Excellent. I might need it to be bigger. Yeah. So this is going to be a work in progress. Do a cool helix movement because that will make me feel like Neo, and I really want to feel like Neo. Okay, awesome. That'll be cool. All right, so there's my path. Let's get this all kind of hooked in. So what I'm going to do, I'm going to make a locator, and I'm going to take that locator and I'm going to constrain it in item mode to the path. Let's go over here. And let's do setup, modifiers. There we go. That bad boy's in there. I'm going to grab my camera, and then I grab my locator, and I'll do a positional constraint. And my camera is somewhere. Oh, I turned the visibility of my camera off, which is why we can't see it. And the reason I did that is so that I can, the path constraint is on the locator, so I can just grab its let's see. Let's keyframe this, or the course, oops, excuse me. Let's see, on frame 0, the path percentage for that locator will be 0. And then over, let's see, where's the action take place? Right in there, I want my camera to be down over here. So it's going to be a really quick movement, actually. Maybe a little too much. Let's change it. Let's change it to a good 120 frames. Good couple seconds. All right. So help me out here. Let's think about how we can use some of our constraints to get a really easy, more easily controllable camera. Okay, because I have the position of the camera dialed, but the camera isn't looking at anything. It's always just kind of orientated off the side of my screen. Does anyone have an idea of how I can have it always looking at one of these elements? I love it. Let's do a locator. Okay, and then we can place that locator wherever we want. And we can animate that locator's position if we like. So I want my camera to look at that locator. So the directional constraint, haha, looking pretty good. Let's split our viewport in two. Change this to, oh, yeah. Okay, so now I need to figure out where I want that locator to be. Since this is kind of, in essence, kind of like the mini target of my animation. So maybe I want this to be initially positioned down here. We're going to set some keyframes on X, Y, and Z here for that locator. And right about in here, let's change its location to look over in there. Okay. And as we continue to go around, Yeah, I'm not sure if that would work with a dynamic simulation, but yes. Yes, we're actually going to talk about something here in a minute called constraints. Or we've talked about constraints, but we're going to add constraints into our dynamic simulations. And I'm not sure if that would work, but there is one called intersect. So maybe. All right. Let's. Now this is my camera move. Woo! Awesome. Epic. I love it. Just like the Matrix. But now let's change and let's make the bullet time. So if I go into the solver and start animating the time scale, I want to have, let's see, right about there, I want time to stop. Excellent. So I want to place a keyframe, and I wanted to ease into it. So I want to put a keyframe on frame 20 or 24. Then right about frame 60, I want it to be frame 0 or 0%. Okay, let's run the sim. This is something we'll have to cache. We can't get a live preview of it. There we go. Let's play it now. Awesome, huh? That's pretty cool. And they slowly ramp in over the course of 20 frames. Each one of those balls slowly stops. Okay. We can also do the reverse. Maybe, let's see, my camera movement stops right around 120. So maybe around frame 100, we have it go the opposite direction. We put another keyframe in there. Then right around there-ish, maybe 20 frames or so, get their fingers. We put it back to 100, and we'll restart the sim. So this is a global operation. We're adjusting how time is influencing our sim. I'm going to keep going. Isn't that cool? Time scale. Love it. Love it, love it, love it. It's a fun little feature of the Modo dynamic simulation world. To go backwards? Let's find out. I've never tried, but, you know, let's get crazy. We're breaking this today, Alex. Let's go negative 100. I bet you the answer is yes. Yep. That's awesome. Look at this window over here. Oh, I didn't run the sim, sorry. It restarts. No. Damn. Did something in there. Guess not. Oh, bummer. That would have been fun. That would have been really fun. Okay. Anyways, now I'm literally playing. Okay, so I need to move on. Yes, sir.
How is this different from doing some of the adjustments when you do the graph editor? The choices you have for slowing time down or speeding?
Well, you can't slow time down in any other specific. No, we're physically slowing time down on the simulation. Okay. In the graph editor, we can create the illusion that things are moving slower. With this, we're actually making them go slower. Yeah. All right. The last thing that I want to talk about today is constraints. Okay. Constraints inside of our dynamic sims are pretty neat. Okay. And this is something that you're going to want to apply. Let's make a new scene here. This is something that you'll want to use for your homework. Okay. All right, so I want to create just a very, very simple example, okay? For your homework this week, you're going to be destroying a brick wall. And there are a number of ways that you can destroy your brick wall and create your brick wall. But I wanted to end today's conversation about, in addition to the dynamic simulation world, that can give us a little bit more control as to how certain objects within our scene can influence each other, okay? They're called constraints. And I want to show you that we don't necessarily always have to have gravity pulling things down and pushing them. We can make things swing pretty easily by employing these constraints. It's really kind of neat. Let me show you how to set it up. It requires a couple different active and passive rigid bodies in the scene itself. So let me just make, oops, excuse me, clicked on the wrong button. All right, so in this new scene, I'm going to have, let's just do a cube and a sphere. Go. And I'll move my sphere way off over there. Okay, now I chose these two elements specifically because I think it's going to be really easy to understand what's going on within the scene itself. Okay, I want to have this sphere swing around like a pendulum around this point. Okay, now with our dynamic simulation system in tow here, we have to do a couple things before we can go too much further. Okay, now I want you to tell me which type of element, which type of dynamic element each one of these needs to be. We're not going to use, so this is a new type of constraint. These aren't like the setup constraints that we've been working with the rigging controls. These are dynamic constraints, okay? Remember, the box needs to stay stationary. The sphere is going to rotate around it like a pendulum.
Is this where you make an anchor?
Nope.
So the box is passive and the sphere is active.
Bingo, you got it. We still want the box to be a player within the simulation, but we ultimately don't want it to move, right? However, we do want the sphere to move, to rotate around like a pendulum. Okay, so let's go ahead and establish those real fast. I'm in item mode, select my box, that's going to be passive. Select my sphere, it's going to be active. Let's test it. Make sure everything's working the way it's supposed to work. Yep, okay, perfect. We got the result that we should have expected, right? The box, since it's a kinematic, passive, rigid body, it's staying stationary, and the sphere falls because it's an active, rigid body. It's dynamic. That's what we want. Now we need to make a relationship between the two. We physically need to create a connection between these two elements to get the movement that we're after. Okay? If you notice, we have some really neat things over here. All right. So we've been focusing on this part of our interface for our dynamic tools. Now we have all of these. These are the dynamic constraints. Dynamic constraints. Okay, I'm not going to go through all of them, but I am going to talk about hinge because I really like hinge. Hinge is kind of a fun one. I've also worked with slide hinge. This one's a little bit more difficult to set up, but it's still a lot of fun. Okay, let's just work with hinge. Now we have to set up the relationship kind of like, or we have to select the elements within the scene, very similar to the way we selected and constrained elements when we were rigging. I want this element to be connected to that element. So the selection order is a player. So select that one first, then we select that one. Let's apply the hinge constraint. Ah, cool, huh? Get this little interface. Let's watch what happens if I just hit the play button. Not a damn thing. Oh, it crashed. No! It crashed. Okay, let's reopen. Luckily, I was working with a very simple scene. No, I don't want to send a bug report. Okay. Let's do it again, shall we? Make a sphere, make a cube. Let's get all of this kind of dialed. Okay. Let me turn off my lights and my cameras. You keep. Okay, let's grab our sphere and in item mode, there we go, Pat. Make sure you're doing all this in item mode. This is going to be a barrier if you're not watching on this. Okay, let's go ahead and make that a passive rigid body, that an active rigid body, and we'll make the connection between the two. Do a hinge, and there's our little connection. If you look carefully, we also have a new constraint, a dynamic constraint, show up in our item list, and we have a number of properties down here that's going to affect its outcome. We'll talk about some of these properties here momentarily, but let's get this thing going. That's right, I got to cache it. There we go, let's play it. Why didn't that work? Okay. Hold on a sec. Yeah, that's what the, let's, hold on a sec. Hello, cube, or not? Gosh, this drives me crazy when I prep something and it totally worked when you prepped, and then I do it here and it's utter failure. Okay, let's try this. Let's zero this guy out. Okay, maybe it's I think I know what was going on. Duh. Okay, passive rigid body. active rigid body. Let's test it. That one falls. Bingo. And then that one, connect to that one, do the hinge. Now it works, because what's important is this center disk. See how this center disk is parallel with the line that's going in between these two elements? Yeah, now it's working the way it should be working, okay? Yeah, like a pendulum, pretty cool, okay? And when I had the, whoops, I hit undo. That was my fault. It's the end of the week, I'm getting punchy, okay? If the disk is 90 degrees, you can select it and then just rotate it, okay? Or you should be able to rotate it. Let's rotate it 90 degrees. Yeah. Now, when the disk is, basically the disk is going to describe the movement that's allowed, okay? So think of it like a hinge joint, and you're only going to establish rotation along the path of the disk. So it's not working at the moment, because the orientation of that disk and the orientation of the constraint is the wrong way. So if I return it back to something like this, now it'll work. Say again? I'm just rotating it. I'm just rotating it right in here, okay? Sphere's going into the box. Yeah, sphere's going into the box. So a couple other things before we get that sphere not going into the box, because that's clearly not what we want. Okay. Couple things. You can change the location of your constraint just in item mode. Maybe I want the hinge to be closer over there. Now it's going to work like that. Okay. Pretty cool. Let's answer Mr. Mays, Alex number 1's question. How do I get this from stop going into the box? Okay. Well, but we can still establish collisions. Okay, we can still generate collisions from it. And what we need to turn on is sub-collisions in the actual dynamic constraint. And now it should bonk, bounce and hit the cube. Bonk. Okay. Now you can do some really cool things with this. What if I add in another sphere? Let's move it down over here. And shoot, let's get crazy. Let's make another one. Yeah, I can do that. That's easy. That's really easy. We can absolutely do that. But I want to show you a really cool feature of this hinge constraint that makes it pretty neat. Let's make these active rigid bodies so that there are players into the mix here. And let's establish a whole series of hinge constraints between this entire chain. Now, I want to select all of my hinge constraints and just ensure that sub-collisions is turned on. Boom. That way, they're all going to bounce into each other. And a few of these, I want them to be kind of in the center of my sphere. And I'll just eyeball it for the time being. There we go. Awesome. Let's play it now. Woo! Vroom. Ah, there we go. Pretty cool, huh? Pretty cool. Now, and that's just going to go forever. That's just going to go forever, which is kind of neat. One of the cool things about working with these hinge constraints is that we can break them at any time we want. Okay, if I select the hinge constraints, check it out. We can also set rotation limits, which is pretty neat. So if we only want to have the hinge go a certain angle within the scene, we can limit the rotation values. And we can also make them breakable. Check it out. So when they get to a certain velocity and a certain force within the system, they're going to break apart. The hinge is going to completely shatter. Let's see what happens now. Boom. Let's lower that value a little bit. Let's put it to 0.25. And now let's see what we get. Oof. So the moment that element right there gets a lot of weight and a lot of force applied to it, it's just going to break its connection and they're all going to fall apart, which is pretty neat. I'll tell you what, on that first one, I'm not going to make breakable. I'll leave these other two to be breakable, and let's just see what we get. Oh, yep, there they go. Pretty cool. Okay, maybe a value of 0.25 is a little bit too low, but it kind of illustrates that we can have more than one setting here There we go. Ah, I love it. And then they're going to spin off down there forever and ever and ever. I love it. Pretty cool, huh? I love working with these constraints. They're a tremendous amount of fun. They allow us to kind of glue things together and then break them apart. We're going to continue to explore a number of these elements as we work. However, let's make Mr. Alex number 3's example. Okay, I'm going to do this. Let's get rid of pretty much everything. There we go. Get rid of all of my dynamic constraints. Excellent. And I'm going to start with the locator because we still need an element for these things to be pinned to, right? All right, so I'm going to start with a locator, and shoot, I'll just clone that locator. And yep, that'll work. Something like that. Cool. Cool. Awesome. All right. And now let's make some spheres. And I want to move this one. I'll move this one down. There we go. And now I'm going to clone, duplicate that item. Yes, great idea. Absolutely. We'll make it an active rigid body first. That way all that's copied. Brilliant idea. And there we go. Excellent. Very cool. And now I just have to go in and say you're going to be, you could use a hinge. Hinge would work. Okay? Hinge would work. Hinge is probably the best one here. And then I'm just going to take all of those constraints and move them to the exact same location as the locator. Are they initially touching each other? Yep. Well, no worries. We can do that. Let's do a little drop action. Let's do match position. Oh, yeah, that's not going to work. There we go. I can do it individually, though. Just do a little match position drop action here so that the rotation element, or the location of rotation for this constraint is at the exact same location as that top locator. Does anyone remember what it's called? It's like Newton's cradle, I think, right? Okay, there we go. And now, to fix our little problem, oh yeah, that totally didn't work. I thought I was going to be so smart and like do it all magically at once. Yeah, that totally didn't work. All right, well, I'll just have to do this. I can do it on the locators. Bring them a little bit closer together. That may be too close. A little too close. Yeah, I'm trying to make them all straight lines. That's all. Should have written down at what value I scaled those to, so everything matches. That's all right. This is just a demo. Fail. Hold on a sec. Yeah. I could do that. Or I could do this. There we go. All right. All right. Let's move this one. Change my actions. Okay, perfect. Let's see what happens. I have no idea what's going to happen. Oh, you know what? Actually, to be honest with you, I've set this thing up entirely wrong. Yeah. Yeah, I've done this wrong because in order to move this element to a point where it'll do the cat's cradle, I had to move it, which has then made the distance between its center point and the center of the the center of that locator, or center of the dynamic constraint shorter, so it's not going to work. However, I have a solution. See, this is what's going to happen. It's not going to hit. Boom. Oh, those hit each other, which is kind of cool. It's not going to hit. See how this one's shorter than all the others? Okay, so let's talk solution. I know how to solve this, but do you guys know how to solve this? Nope. Nope. Nope.
Start going down, start it with a force going to the side.
Interesting. That wasn't the way I was thinking, but let's give that a go. That's not actually a bad idea. Let's give it a little impulse along positive x. I like it. I did the wrong one. Excuse me. See what we get? Yeah. Bong. Okay, cool. Kinda. And I think really the problem is that these are not perfectly straight. They're at an angle, which is causing things to go haywire. Although it is kind of neat, isn't it? It's very neat. Let's turn on do sub collisions for all of these. See what we get. Yeah. So we also got to change the bounciness of all of our spheres. Okay, you can stop now. Thank you. Let's put their friction value down to 0. So they're like glass, and then we'll increase their bounciness. Let's see what happens. Let's also make them like a good pound, or 2.2 kg, right? Nope. Yeah. So we got some things to troubleshoot in here, but we're not too far off. I mean, the basic setup is kind of what we want. Okay, I'm not going to force you guys to sit and watch me troubleshoot this, but it kind of works. Kind of works, and for the moment, that's I'm okay with that. Bong. I don't think my spheres are heavy enough.
No, it's not twisting because it's not allowed to twist. It's not allowed to move in that direction.
Yeah, why don't we just try my idea first? Let's see what happens. Oops. All right. Let's get one dialed. That's awesome. What I'm looking at is the rotation of those constraints. Yeah. They shouldn't be rotating around their locators. So let's see what happens when we limit the rotation on these guys. Yeah, I'm still not getting the interactivity between these two spheres. Do collisions is on. Excellent. They're all dynamic. Perfect. Perfect. Anyways, I could spend all afternoon troubleshooting this. I think what I've created here is a complex setup, and the solution should be troubleshooted in a very simple environment. Yeah, I'm not so sure that's the reason why it's not. why that's yeah. It is a very nice disco ball. Well, anyways, I'm not going to sit here and troubleshoot this all afternoon. I wanted to show you one final thing this afternoon before we move on, and it's a tremendous amount of fun. And this is really kind of a tease into next week because we've been influencing hard objects. Well, what about soft objects? What about objects that are? What about objects that need to have a little bit of elasticity in them, like a trampoline? Yeah, like a trampoline. All right. Alrighty, Rant. So I'm going to start with a donut here, because all good demos include a donut at one level or another. Okay. And I'm kind of hungry, so I'm all about donuts. Let's make my plane, my ground plane is a little bit bigger. Okay, so we're going to do the same type of things. This ground plane is going to be a passive rigid body. Okay. And if we were to make this an active rigid body and just hit the play button, well, there it goes. That's kind of boring. So let's make it bouncy. Let's make it really bouncy, 100% bouncy. Let's see what we get. Cool. Let's also give it a little bit of a torque. Well, instead of doing it a torque, we'll just put it at an angle. That way, it'll start to, there we go. Great. Let's make the dynamic plane here bouncy as well. Hey. There we go. Love it. Cool. All right. So that's what we get. That's the type of interaction that we're used to seeing with active rigid bodies. What about active soft bodies? Because not everything needs to be a hard shell. A lot of times when you're working with complex scenes or scenes with characters or fabric, you want them to be soft bodies. Okay. Well, we also have this soft body in here as well, which is kind of cool. So instead of reapplying the tag, I'm just going to go into its type and change it to soft body, and let's see what happens now. We get some additional options here, which we'll talk about in a second. Oop, and this is something that the computer has to figure out. Go. Now, if we play it, not a single thing happens. What happened here, Pat? Let's increase. There we go. Okay. Never mind. Let's not do that at all, huh? Okay, I just hit undo a couple steps here. Let's get it back to, yeah. Okay, great. And it crashed. It must know it's the end of the week. My computer is already looking forward to the weekend. All right, let's try this again. There we go, that'll do. Say again? That's the idea. Yeah, that's the idea. All right, let's try this again. This time, passive rigid body. This time, soft body. Let's run it now. Okay, let's increase some things here. I'm going to go on my ground plane, make it real bouncy. I forgot to do that earlier. Do you guys see that? Let's look at it from the front. It actually starts to deform. Kind of jello-y, yeah. So it's an elastic object now. And this is where, oops, I'm in the wrong. I got to make sure I have my donut selected. There we go. This is where all of this stuff kind of comes in. The stiffness bend, the structure, and the shear amount. If we increase or decrease this to like 0.5 0.1, it should bend more. Yeah, there we go. Now it's trying to preserve less of its original structure as it's hitting the ground. Let's also decrease how its bend percent